Good morning, everyone. Today we're talking about 10.3, quotient of powers. So you should have already mastered the multiplication part of this. Now we're going to get into dividing. So our question of the day is, how do you divide powers? So before we get into powers, let's talk about fractions. Let's do a review of fractions. Remember, to simplify or reduce a fraction, you can cancel things out that are the same in both the top numerator and the bottom denominator. So let's look at some. If we had 6/3 and we want to simplify that, okay, looking at this, 6 divided by 3, we already know the answer, but let's pretend we do it in fraction way. So let's take 6 and split it up. 3 times 2 is 6, divided by 3 is still there. Since the 3's in the numerator and denominator are the same, they cancel out. They're gone. 3 divided by 3, that's 1. So now we've got 2. Let's look at another one. This one is 17/21. So let's split up 14. 14 is the same as 7 times 2. 21 is the same as 7 times 3. What is the same here? The 7's. So we can cancel those out, and we're left with just 2/3. We're going to use this tactic today. Now let's review powers. What is a power? A power has a base and an exponent. So let's look at what that looks like. Here is a power, x to the third. That is the same as x times x times x. We're going to use this and the idea of simplifying fractions for these problems following. We also know that when multiplying when multiplying powers, the bases must be the same, and then you just add the exponents. That was from our last lesson. So we see an example here. Simplify 2 to the third times 2 to the fourth. Well, expanded, this is what it looks like. 2 times 2 times 2. And then 2 times 2 times 2 times 2. How many 2's do you have there? 1, 2, 3, 4, 5, 6, 7. So 2 to the 7th. If you want to use the shortcut, all you had to do was add these two together. 3 plus 4 equals 7. Go ahead and pause the video here if you need to write any of this down. Moving on. So let's try, before we even learn what the quotient rule is, let's go ahead and look at an example. Simplify. Write your answer as a power. Okay, that means we can't just use our calculator because they want it written as a power. They want to make sure you know the rule. Well, we haven't been taught it yet, but we can use our knowledge of powers to simplify this without even learning the quotient rule yet. So let's look at this. We have 3 to the 5th divided by 3 squared. Well, let's go ahead and expand. 3 to the 5th is the same as 3 5 times, right? 3 times 3 times 3 times 3 times 3. And then the denominator, there's only 2 of them here. Now we can cancel things out. Cancel out the 3's that are the same on the top and the bottom. 3 divided by 3, done. 3 divided by 3, done. And that's going to leave us with 3 to the third. Not too bad. Some of you may already be thinking, oh, I know what to do. I know how to do this an easier way. Let's try one with some variables. Variables. Let's try x to the 5th divided by x to the 4th. We're simplifying again. x to the 5th divided by x to the 4th, 5x's. And this one has 4x's. Let's go ahead and cancel anything that is the same on the top and the bottom. Cancel, 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 cancel. This one doesn't have any to cancel with. So this would just be written as x to the 1 or just x. Either one of these would work. Let's mix it up a little bit. Let's throw in 4y to the 7th all over y squared. 4y to the 7th divided by y squared. So I'm going to expand this. This just means 4 times. It's kind of annoying when the numbers get a little bigger, huh? So the 4 doesn't have anything to cancel, so that stays there. But I can cancel out this y, and I can cancel out another y. So that leaves us with the 4, and how many of these y's are over here? 1, 2, 3, 4, 5. 4y to the 5th. Done. Now, what would happen, though, if we were given something like y to the 500th all over y to the 100th? We are not going to want to draw out 500 y's and 100 y's in the denominator. That will take us all day. So, let's talk about the rule. How have we been getting these answers? Let's try to find a shortcut here. I'm going to go back to that first example. We had 5 3's and 2 3's. Our answer left us with 3 3's. We had 5 x's and 4 x's. In the end, we only had 1 x. Here we had 7 y's and 2 y's. We were left with 5 y's. How are we getting these numbers? Well, that takes us to today's lesson, the quotient of powers. Okay, and one more time, bases must be the same in order to do this. Subtract exponents. That's how we're doing it. Okay, and if you ever forget this, you can just expand out, right? So going back to that example of x to the 5, I don't know if it was x or y. We're going to use x this time. X to the 500 divided by x to the 100. All we're going to do is take that numerator minus the denominator. And that's going to leave us with x to the 400. Let's try another one. Y to the 10th divided by y to the 7th. Y to the 3rd. Okay, and you notice all of my numerators have more in the top than the bottom. That's done purposely. We'll look at some examples on Wednesday where that's not always the case. Now let's talk about combining multiplication and division. Remember what PEMDAS stands for. It says deal with any exponents, then multiply first. Multiply, then divide. So if you see an example, let's go with x to the 5th times x to the 9th. X times x to the 8th. Before I start dividing, I need to multiply first. Multiply first. So let's go ahead and do that. X to the 5th times x to the 9th all over x times x to the 8th. Remember our rules. For multiply, we're really adding the exponents. And down here we have x to the 1 plus 8. Remember, if there isn't an exponent there, there's an invisible 1. So that's going to get us x to the 14th all over x to the 9th. So now that we've multiplied, now I can divide. So we're going to take x to the 14 minus 9, which is x to the 5th. And I think we're on the last problem here, everyone. Last one for the day. And then you have an online big ideas assignment. Let's go with 2 variables this time. So let's try m to the 10th times n to the 7th, all divided by m squared n to the 5th. There is no multiplication here, but there are 2 variables. Remember, if the bases are the same, you can apply this. So we have m 10 minus 2 times n to the 7 minus 5. And that gives us an answer of m to the 8th n squared. All right, folks, that's it. Go ahead and log into Big Ideas. Have a great day.